Hey, it's Dr. Mike T. Nelson. Welcome back to the Flex Diet Podcast, where we're focused on increasing your performance, better body composition, and all without destroying your health, even increasing your longevity. Today on the program, I've got an interview with my buddy Thomas Phillips, and we went kind of all over the board on a whole bunch of different topics he wanted to pick my brain on. So big thanks to him. Everything from metabolism to heart rate variability, glucose monitoring using a continuous glucose monitor, and much more. As always, this is brought to you by the Flex Diet certification. Go to flexdiet.com, FLEXDIET.com. You'll be able to get onto the wait list there. That'll also put you onto the semi-daily newsletter. I've got some great stuff for you, and we'll leave it as a mystery, something I'm doing only for newsletter people coming up. I think you will enjoy. So go to flexdiet.com and enjoy the podcast today with my discussion with Thomas Phillips.
So first of all, Mike, thanks again for taking the time to do this. Last time,
Yeah, no problem, man. I appreciate the questions.
Yeah, so just real quick, because I just want to give a quick overview of what we did last time. We talked about heart rate variability and the Whoop system. And since we spoke, I am now 100% pretty much positive that the HRV that Whoop uses is, in fact, an algorithm, that it's not actually measuring HRV.
I did confirm that for the most part too. I talked to Joel Jameson.
So I'm, which is disappointing. Had I known that, I would have never invested in it. And just so you know, I mean, I don't know if we went over this last time, but ever since COVID started, I used to do what's called the Ultimate Transformation Challenge, and I go through, a very comprehensive nutrition program. But when the COVID started, I didn't have access to the gym, obviously, and I started to do what are called 40-day challenges. And I figured, you know what, let me start with the immune system. And for 40 days, I did 20 minutes on the immune system. And then people loved that, and they wanted to have more information on this and then that. And so I decided, you know what, I'm going to start doing these topics. And obviously the last one was HRV. So I wanted to let you know that this one we're doing, I was actually able to get constant glucose monitors.
Oh, nice. I just got off a consulting call with a guy from Germany on that.
Yeah. So this one right here is by Abbott.
Yeah, freestyle. Yep.
Yeah, exactly. So I have 20 people doing it with me. I have a connect to be able to get these things, but I haven't started it yet. And I didn't start it yet on purpose because I actually wanted to get your thoughts on this, tell you what I'm thinking, and just do it better based on your feedback.
Yeah, cool.
So here are some of my thoughts, what I'm looking for with it. Obviously, I think the average person will find that they're probably type 2 diabetic. That's the first thing. But more importantly, just how the perception of what's quote unquote healthy food for some people might not be so great for others, specifically when it's carb based. I have noticed myself that I react much better to certain carbs than others, even if they're supposedly good. And just in general, I wanted to talk a little bit about obviously the benefits of keeping a healthy blood sugar, but then when it is advantageous, say post training, to put in some to spike your glucose and therefore insulin and whatnot. So any thoughts about what I'm doing here, Mike? And what do you think of this endeavor and what I'm looking for? Is there anything else that you'd be curious to see from the experiment?
Yeah, I mean, one, I'd love to see the data. I think that's super interesting. My bias on how I've set it up with people is the new ones are 14 days. So my bias is to split it into 2 weeks. So I tell people, take the first week, don't change anything. Ideally, if you could not even look at the data until you've completed that week, even better. Because I want a nice snapshot of like where your baseline is, what you're doing, what's going on, Obviously, log your food with your timing, your exercise, and some sleep, so you can go back and look at it and see what was going on. Because the biggest mistake I see with people now that they can get access to the readers and everything is they do one day and they look at it and they start freaking out and they start changing 1,800 variables and they get so confused by day 4 they don't know what end is up. And as you know, like it can change based on sleep, it can change based on stress, the food. There's a whole bunch of stuff that goes on. But the main question you want to answer at first is, what was my baseline and what was good and what can be changed? So then at the end of usually that 7th day, I'm like, okay, let's take a period of time. Let's look at your data. Let's just look for associations, just like HRV. You know, yes. Oh, wow, it looks like you had 3 nights of poor sleep and it looks like the next day wasn't as good. Or, wow, I had white rice. I thought that was a, quote, good food. My glucose was high after. So this will give you, I usually have people start with like 2 to 4 little experiments that they would then want to run. Right? Yeah. So like, okay, if I sleep more, does that look better for the next week? Or what are like the 3 foods I kind of want to test? Right? So let's say white rice is one. So then I'll say, okay, take a morning time because that's going to be a little bit more stable. And as weird as it sounds, like just eat a shitload of white rice for breakfast.
Yeah.
Right? Because that's going to be the most stable period of time. It's in isolation. Is it kind of an artificial thing? Yeah, absolutely. And then see, are you able to reproduce it? If you are, okay, then you can play around with what you want to do to modify it. So I view the second week as modifications and testing the extremes.
Yeah, I love it. That's actually a great idea. And what I do like about Whoop, though, is that it's actually very accurate at tracking the sleep. And
it's not bad for sleep, actually.
Not bad at all. So I like the idea of combining. Obviously, we talked last time about Matthew Walker and his work with sleep, and he's talked extensively about how poor sleep affects blood glucose along with many other things in your brain. But that's awesome. So some of the other things I'm planning on discussing during that challenge are basic things. I don't know if you've heard this research that apparently just a 10-minute walk after you eat is as effective as metformin. Have you heard this?
It can be in some people. Yeah, because you have non-insulin mediated disposal, basically.
Yeah. I mean, so basic things like, in terms of like having some protein and a little bit of fat with your carbs, just basic stuff that I think people don't realize how simple it is to kind of mitigate some of these problems that you can have with insulin response. Do you have any other suggestions as far as how people can, other than sleep and exercise, obviously, and combining some protein and fat, any other little tricks that you found that map onto glucose that maybe aren't as well known?
Yeah, so there's a couple things. Movement is a big one, right? So most people are familiar with, if you get in the weeds, like the insulin-mediated uptake of glucose, right? So insulin causes a GLUT4 guy, goes to the end of the cell, it sucks in a bunch of glucose. Most people are not as familiar with, like you talked about walking, the non-insulin-mediated uptake. And there's some studies showing that may actually be a bigger portion. And all that is just simply muscle contraction in and of itself, independent of insulin, can actually start pulling glucose out of the cells. So like going for a walk in the morning, going for a walk after meals, you have some insulin release. Just muscle movement, because I think, and John Berardi said this years ago, he's like, all these people say they're active. He's like, yeah, you train hard for 45 minutes a day, but then you sit on your ass for the rest of the day. And that's good. Training's good, but movement helps too.
Yeah, we talked last time about how important NEAT is, right?
Yep.
How, taking the stairs instead of, going up the escalator and purposely parking further away in the parking lot in order to get more steps in. Just this base, I've promoted a standing desk forever to people. Be weight bearing on your hips, find ways. There's even stuff with people that fidget, right? That they find that they have, so great. That's great stuff.
Another couple things I would add too would be there's some very interesting stuff with where the spike occurs in the blood glucose, right? So if I see someone who, and again, CGM is pretty good at measuring an interstitial, but if you see someone who spikes super high and then it drops super fast and then you've got this longer kind of tail to it, there's two main phases of insulin release. The first one is a cephalic release, which is primarily modified by your nervous system. The rest of it, the kind of standard insulin response, as people think of it, is more related to the hormone insulin itself. So if I see people who have like this really big spike and then it drops and still is a little bit of elevated, my thought is maybe there's something going on more with their nervous system. So I'm going to ask them like, okay, where do you eat? Oh, I'm a trainer. I'm eating while I'm running to my next client, right? Oh, so you're eating in like a very stressed out state a lot of times, or you're watching something stressful on TV versus, yeah, I decided to eat outside and stare at a tree. Okay. You know, it's more on the theoretical side, but I think you'll see different responses to that. And we know if you get stressed, right, you're just going to start pulling, blood flow away from your gut and that type of thing too. So sometimes you can parse out that too.
Yeah, I mean, what isn't debatable, we spoke about this last time, is that your parasympathetic system really is your rest and digest. And when you're training, you really are very, very sympathetic, and it's the opposite, right? Your blood flow is everywhere but in your stomach. It's paying attention to everything but digesting. So that example of training as a stressor is great because everybody can relate to that. But your point, just emotional stress, right? You're going to have more difficulty digesting under emotional stress, or again, to your point, lack of sleep, right? If you only had 2 or 3 hours of sleep, that's a type of stressor. So I like that. Is there anything else you could think of before I kind of delve down a little bit more? I want to talk a little bit more specifically about insulin as well.
Yeah, my other caveat is, which you probably have coming up, is that we're still only looking at blood glucose. And that's good, and that's a really cool window. But I did a study that was, long story short, it was 1.5 years of my life and never got published, which is a whole different story. And we were looking at people that were borderline type 2 diabetic. We were looking at if, walking was an intervention. We didn't really do it timed or anything like that. But we had people walk, didn't walk. We pulled blood glucose. We pulled insulin. We pulled all these bloods off them. And when you go to run it, blood glucose is very easy to get, but the insulin data takes a little while to come back. So initially I had all these people that had all their blood glucose, and they're borderline type 2 diabetics, so they're definitely kind of uncontrolled. I'm like, yep, that person's high, that person's high. And then when I got the insulin data back, some of the people who were high but not crazy high, their insulin was sky high compared to other people where it wasn't. Right? So the person with the sky-high insulin is definitely closer to a diabetic state, but their body is able to compensate and kind of keep blood glucose a little bit lower by putting out a massive amount of insulin. Right.
So this is sort of part of where I wanted to begin this conversation. And this is what I understand, and you correct me as I go along. Sort of as blood glucose stays high over time, right? Somebody is not eating well, and they're eating, refined carbs, lots of sugar, blah, blah, blah. And it goes on for a period of time. Insulin will raise precipitously with that, right? My understanding, though, is that eventually, though, right, as the blood glucose goes up, insulin comes up with it. But eventually, whether it's 6 months, a year, or 2 years, the insulin actually starts to come down. And eventually you can have a very normal-looking insulin with high blood glucose. Have you heard this?
Yeah. So what happens is, imagine if one line is insulin and your other line is glucose, right? Because your body goes, hey, I have to control blood glucose as tight as possible. That is the main thing, no matter what. If it's obviously beyond insulin, but the whole system is set up that if blood glucose goes way too high, it's very toxic. Now, again, does that normally happen? Extremely rarely. But your brain goes, okay, we need to dump it somewhere. We need to convert it into fat. We have all these other counter-regulatory hormones, blah, blah, blah. But if we just look at glucose and insulin, you're correct that blood glucose can go up and insulin can start going up. And what you'll see is the two curves will start becoming disproportionate. Glucose is going up and insulin starts rapidly going up. You'll see this inflection point in the curve.
Right.
But then at some point, especially as they breach into like a type 2 diabetic, now you actually start having a problem with insulin production, right? The cells that produce it start having issues. And then you're correct, insulin production starts going down. The body says, hey man, we're putting out as much as we can. We're actually starting to have damage to the cells that are producing it, and we just can't put out any more. And we're actually starting to go backwards now. And at that point, blood glucose starts becoming really uncontrolled.
Yes. So that's really the problem. I think people get this idea that, this is something that happens in a short period of time, but it actually takes a little while for that.
That's many years, actually.
Yeah, years.
Yeah.
And once that happens, people don't realize. I mean, you've actually caused, problems to your pancreas, to your liver. There's your liver enzymes are likely high.
Yep.
It's just overall unhealthy situation. But the good news is that we can reverse this, right? Most of the time, this is very reversible. And people that I've worked with over 20 years, I've seen this reversed in about 3 weeks, meaning like you start to see very normal blood glucose. Now that's people that are being vigilant. They're right on point. They're doing what you asked. They're moving their bodies. They're getting enough sleep. But in about 3 weeks, you can see this crazy change in their body and in their blood glucose. And part of that is because your body is just so rapidly, turning things over so quickly, right? Yes, you may still be 50, 60 pounds overweight, but you've created an environment in the bloodstream itself where it's much more conducive to, a healthy lifestyle. Is that accurate on your end, Mike?
I would say so. I mean, the time course is probably debatable, and there's a lot of variability in it from what I've seen.
Yeah.
And the part that we don't necessarily know is we do know that if you get really far into being a type 2 diabetic, you probably have no other choice than to be on some type of insulin. Right. Now, again, if you can make your body very healthy, very sensitive to insulin, you may not need much of any. And some of those people we're finding that we thought would be on insulin the rest of their life, they could probably come back a lot closer to healthy than what we thought before.
Right.
But either way, the interventions or what you're going to do are going to be the same, right? You're still going to do all the things we talked about. Where you end up, that's kind of debatable, individual, but the action items and the stuff you would do is all very similar.
Yeah. I mean, if a person was willing to be completely ketogenic, total beta oxidation pathway, they really wouldn't need insulin, right? Even if they were type 2 diabetic and were insulin dependent, right? If they were willing to go completely ketogenic, you would agree that the insulin would be pointless.
Maybe. It depends. The tricky part with that is I have a buddy who will remain nameless, but he's a PhD and he's a type 1 diabetic, right? So his body doesn't produce any insulin. Now, right. I do not recommend anyone do this experiment, but he went completely ketogenic, and for periods of time, he cut his insulin like dramatically to almost nothing. Now, again, I would not recommend that to anyone. The issue is that if you have absolute zero production of insulin, you can end up what's called diabetic ketoacidosis. So insulin, even in tiny amounts, will cross-check how much production of ketones gets spit out of the liver. So in English, that means if you're a healthy person and you do a ketogenic diet, the amount of insulin you're producing dramatically goes down, but you still have a little bit that's being produced. And that little bit that's being produced prevents ketones from going dramatically high. So if you're healthy, you can't ever really run into a problem with too high of ketones. Now, if you drive that insulin production to absolute zero, then you could end up having an unchecked production of ketones, and you can end up being what's called diabetic ketoacidosis. So that is a real thing. It can happen. But again, that's in people who are very advanced disease state. Most people who are healthy wouldn't have to worry about it. But the amount of insulin, even in that case, goes down dramatically.
That was a type 1 diabetic, though, right, Mike?
That's if you drive insulin to absolutely zero. Yeah. Correct. Yeah.
But that the example you just gave, though, your friend was a type 1 diabetic.
He was a type 1 diabetic, which is why it's tricky, but
Yeah.
he also, I mean, he's actually spent 7 years of his life studying this in a lab. He's lived his whole life as a type 1 diabetic. So he's pretty good at knowing what's going on with his body.
Yeah, I'm just no. What I mean is I'm saying saying specifically for a type 2 diabetic.
Yeah, so type 2 diabetics, most of the time they do have some insulin production. It's probably not sufficient. And if you do have some insulin production, your odds of, having super high ketone production, probably unlikely. Because even that tiny amount of insulin production, even in a healthy person, that's enough to prevent the ketones from going just through the roof. So most of the time, they're probably going to be okay.
Yeah. Perfect.
Yep.
I mentioned earlier in terms of, just combining foods in order to keep your blood glucose, at a steady keel in terms of fat, protein, fiber.
Yep.
Let's talk real quickly about protein. I know you did a lot of, I've listened a lot to Dr. Stuart Phillips as well, and I think you've done quite a lot of stuff with, and I think that you could say to people who are listening that if you want to know about protein, he's probably the man, right?
Oh, yeah. Yeah, he's definitely, his lab has done more protein research. In terms of tracer studies, there's like a handful of 6 labs in the world that even do that kind of research. So, yeah.
Yeah. So what I wanted to address with the audience listening, because I think this concept gets very hard for people to understand, but I'll tell you how I sort of look at it in this context. So people hear this idea of oh, you know what, I want to get big and I want to get strong, right? And I want to put on as much muscle as possible and I want to perform great. But at the same time, I only want to eat one meal a day because, that's supposed to be really good for you. I read that somewhere. And then I'm also going to be ketogenic as well. But I also want to be able to, deadlift 500 pounds and bench press 300 pounds and go through these workouts that are 45 minutes to an hour long. So the way that I look at it is sort of on that mTOR pathway, right? You can either follow a lifestyle where you're on one extreme that's designed to preserve things, to live to be 120. And in this case, yes, eat one meal a day, obviously, you're still going to do all the things that we talk about, but you're not necessarily going to drive your body the way a power lifter would and things of this nature. You would do things that are, more in the line of, walking, yoga, breath work, things like this. This is great, but if your goal, right, is to have a lot of muscle and to be able to have these crazy workouts, not just in terms of what we're going to talk about in protein, but just in general, it's probably a good idea to eat more meals a day and to obviously follow all these lifestyle rules. But I think people get very, very confused in the world of, health and wellness about these topics. And it's because they don't understand what they're trying to do. They just read things that are quote unquote good for you, but yet we're a results driven society and we want to be able to do things. And unfortunately, sometimes these goals don't go together. So can you just speak briefly about that, Mike, if I'm on the right track here and what I'm describing?
Yeah, so a couple things. So if we look at things that promote longevity, right? So things that we have pretty good data that support longevity. Muscle mass, lower body strength is probably at the top of the list, right? Your ability to get out of a chair, get up off the floor, don't break your hip, all that kind of stuff is related to muscle mass, especially lower body, full body strength. VO2 max, how big is your aerobic engine? How well can your body process oxygen? Grip strength is also a correlate there. The grip strength is probably more just an indicator of full body strength. Again, as you know from lifting, right? I've never met someone who has a really strong grip who's a weak person, right? And I've never met someone who's really strong that has just a horrible grip. They're high associations of each other. If you get into theoretical stuff, yes, reduction of calories may help. I say may because it depends upon what you look at. If you're a friggin' nematode, it's 40 to 60% of just slashing your calories. If you're a mouse, 30%. If you're a primate, if you're a human, even one of the main primate studies that was done got hosed up because one of the people in the lab felt bad for the group that was being calorically restricted and got busted for secretly feeding them.
Yeah.
You know,
Yeah, that's
so
fine.
even the data we have on that, I would say, is highly debatable. So in general, caloric restriction, yeah, you want to be good body comp, you don't want to be obese, that definitely helps. But restricting calories further from that is hypothetical. In terms
Right.
of protein, same thing, right? There, yes, you can find all sorts of mouse studies showing that protein may increase cancer risk. But again, as you scale up to actual humans, in terms of potential risk of getting cancer, I'm not super convinced by that data. And again, I'm not a cancer researcher. And then when you look at the literature, you have to differentiate from people who are reducing their risk of getting cancer versus people who already have cancer. Those are
Right.
like two completely different mechanisms. So there's some mechanistic stuff that some types of cancer, if you already have it and you are being treated for it, protein may or may not be the best idea, but that does not necessarily translate into, oh, I need to have less protein because I want to reduce my risk. Meh, I'd say it's a little bit more hypothetical. So my bias is if someone said, hey, I want to maximize longevity and I want to do it on what data we have now, all the things you said are great. Breath work, reduction of stress, sleep. I'm biased more towards 3 to 4, 3 to 5 protein feedings per day, most days. If you want to hedge your bets on that side, I'll have people do one day of just not eating, right? So take Tuesday, work up and just do a long fast, don't consume any amino acids. Probably good for body comp, might be some other benefits, it's probably yet to be determined. And if you really want to hedge your bets on that side, that's probably what I would have them do. The other 6 days of the week, by all means, run mTOR, lift heavy stuff, like bias yourself into function as best you can.
Yeah, and my clients know that that's exactly what I do. That I do one day where I do I don't eat until 3 o'clock in the afternoon.
Yeah.
Right. So the night before I'm done eating by about 5 or 6 o'clock. So I go about 22 to 20 hours of not eating, and a lot of my clients have done that with great success. Just
Yeah.
one day a week. So along the topic of protein, and I brought up Dr. Stuart Phillips for this reason. Can you explain to everybody this idea? And I brought up that one feeding a day, right? So
Right.
people get the like, but I thought you can only absorb 20 grams of protein, in a serving. So if I have to get all of my protein, I'm supposed to eat my body weight in protein,
Right.
or whatever people are reading, right? And because I want to get big and strong. And I hear that one feeding a day is really good for you because I read it, or listened to Rhonda Patrick or whatever. Can you talk about what is meant by we absorb 20 to 25 grams of protein? At 25 would certainly be on the high end. And truthfully, though, like, wrap it up by explaining to people that all of the protein is eventually absorbed, right?
Right.
But what that we mean about this 20 grams of protein window absorption?
Yeah, so that's one of those myths that gets thrown around all the time and still around. So I tell clients, it's like, okay, hey man, you ever gone out to like a big restaurant and you get like a 16-ounce T-bone, you have it for dinner, and you wake up in the morning, do you take a crap and have like a T-bone shaped poo like the next morning? Like, does it just go right through you because you can't absorb more than like 20 grams of protein? It's like, no, that doesn't happen, right? So most people absorb it, it gets used, it gets broken down into amino acids, no matter how much protein you take in. Now the caveat to exactly what you said is people then are thinking use versus digestion. And
Right.
normally when they think use, they're only thinking about muscle use. So it is true that there is a cap to maxing out what's called the protein synthetic response. So how much protein can I take in? And in English, just jam it into my muscle tissue only, right? Because that's what most people care about.
Yep.
With that, the maximum dose is 20 to 40 grams. So if you look at like whey protein, you can take 20 grams of whey protein. This is in young, healthy subjects on a fasted. And you could double it. You could take in 40 grams of whey protein. The net response of how much ends up in your muscle tissue is still the same. right? Because 20 grams of protein will kind of max out that response. It's like turning on the light switch, right? Once I have the light switch on, if I put more pressure on the light switch, it's not going to get brighter. It's not a dimmer switch. It's an on and off old school switch. If you are older, however, you may need 40, maybe 60 grams of protein to get that same response as someone who's younger. I think it was Tang who did a study comparing 20-year-old individuals to those who were 71 years old. And what they found was a 71-year-old, to get the same acute response, needed 40 grams of whey protein compared to 20. So the dosing as you get older, because of something called anabolic resistance, actually goes up. And then if you get into like rice protein versus whey, like if you want to get about the same response, it's about 40 grams of a rice protein isolate, because it's not quite the same quality.
Exactly.
So that's the main difference with that. And a super cool note on that, so Luc van Loon's lab in the Netherlands, they actually did a study with radioactively tracer labeled protein. It took them 3 years to get the protein. So what they did is they actually had to get cows, and they put the tracer in their feed, and they fed it to the cows, and then they had to monitor the cows. They took the milk from the cows, and they made protein. They gave it to individuals in a study via nasal cannula at night. They literally jammed it down their nose, and then they woke them up with like muscle biopsies in the morning. And what they found was, because it was a radioactive labeled tracer, you could literally trace the amino acids in the body. What they found was a 20-gram dose of whey protein, only 2 grams of that actually got deposited in muscle tissue. So it's a very inefficient type response. But if you add that response up over time, so back to your 1 meal a day, if I only did 1 meal a day, I'm probably going to max out around that 2-gram deposit of muscle. Now, if I could add another maybe 2 feedings, I could triple that. Now, again, still very small amounts, but that will offset the amount of muscle mass that people will generally use with aging, especially if they're not training. So having multiple feedings, especially as you're getting older, is going to be more beneficial.
Yeah, absolutely. I mean, you mentioned, the absorption protein, as far as like foods, eggs would be highly absorbable.
Yep.
Even more so, much more so than whey protein, which a lot of people perceive as, super absorbable. I think whey protein, it's more the fact that I think the concentrations of leucine are so much higher, right? So the signaling is so much is there, right? Maybe talk a little bit to me about like leucine, how sort of branched chain amino acids are a waste of time, right? I mean, like we used to think in the 80s that this was a big deal, but you just enough leucine, right, to drive the signaling, right?
Yeah, so the main thing of how it works is you've got, just like your bank account, I can put money in, I can take money out, but I'm looking at the net response. So muscle protein synthesis is I'm adding more amino acids to my muscle. I'm making it a little bit bigger. Muscle protein breakdown is I'm pulling out amino acids and it's going down, just like I'm withdrawing money out of my bank account. And at the end of the day, we want more to be put in than we want to be taken out. And in studies, there's like 2 labs in the world that only really measure muscle protein breakdown. So it's hard to measure, but most of what's variable and under our control appears to be more on the building up side. Again, that's still a little debatable. So when we have protein coming in, the 2 main things that are going to trigger that muscle protein response is going to be leucine and then essential amino acids. So leucine, real simply, is like turning on the assembly line. So imagine I got my assembly line here, and I'm going to make a bunch of stuff, right? So the first thing I need to do is I need to turn the assembly line on. I need to get the thing running. So leucine is the main thing that sort of turns on that muscle building process. The second part is I need some raw materials to make stuff out of, right? So the building blocks are the essential amino acids. And then the last part, if I really want to crank it up, I need some type of fuel, which is like, as you know, if you really want to add as much muscle as humanly possible, you're going to need to be in a caloric surplus in order for that to happen. You just need more energy to run through the system. So when you have those, all 3, then you're good. Now you can still add some, muscle if you're not in a massive caloric surplus because of the training and everything else. but you mainly need leucine and you mainly need essential amino acids. So if we
Yep.
look at branched-chain amino acids, they fulfill the leucine requirement, so there may be some slight benefit to that, but if you don't consume them with any essential amino acids, you're missing the raw building blocks, and you're going to see, very much of a subpar response.
Yeah, I mean, my point was that more leucine isn't the answer, right? You just
Correct.
need enough. Anything more than that, people think, well, I'm going to slam, 5 grams of leucine because apparently that's the no. You just need enough to start the assembly line. That's
Yep.
really the.
It's
right?
what they call a concentration or a threshold effect, right? It's about
Yes.
2 to 3 grams of leucine, depending on what animal data and what models you use, somewhere around there. You're correct. So once the assembly line is on, it's on and it's running, right? So if I take 8 grams of leucine, it doesn't run any faster, right?
Yeah.
So once you've hit that threshold, like turning the light switch on, once it's on, you're good to go. You've already accomplished it. Adding more isn't going to make the light any brighter.
Then, Mike, how, just hypothetically speaking, if somebody did take branched chain amino acids in the morning, right? What's the half-life of leucine in terms of how long it can sort of keep that window open for the next meal? Let's just say hypothetically your next meal you didn't have enough leucine to trigger that assembly line. Do you know if that first feeding in the morning 4 hours prior, do you still have enough leucine in the system for the second meal?
I would have to look at the actual kinetics on it, but if I were to guess, I think it's only like an hour or two. Like freeform leucine spikes really fast and then decays pretty fast. There's some super interesting data. I was just at the International Society of Sports Nutrition this past weekend in Florida, and Dr. David Church was presenting. He's one of the guys who works in a lab that does Bob Wolf's lab, that does a lot of these tracer studies. And they were showing that even a greater acute response with essential amino acids fasted, even compared to whey. Meaning that if you compare essential amino acids to whey, more of them show up in the plasma and get to a little bit higher rate acutely in people. Now, we don't know, does that translate into more muscle mass or not? We haven't really done a lot of those chronic training studies per se. But we do know that essential amino acids do show up faster. And I think in the future, to your question, we might be back again to the kinetics question of how fast these things show up might be more of a factor than what we think. But again, that's also down in the weeds and you're splitting hairs. So if someone said, hey, I really want to hypothetically maximize my muscle response, I'm already getting the amount of protein that I need. Was there anything else I can do? I'm already training hard. My sleep is good. Hypothetically, you could say when you first get up in the morning, consume, and their study is up to even 15 grams of essential amino acids first, and then maybe wait a couple hours and then have a normal meal, kind of go by, about your day. Again, hypothetical at this point, but we do know that does trigger that process via the high levels in plasma.
I just want to be clear that to people listening, because I know that this may be confusing to some people, but essential amino acids are not the same as branched chain amino acids.
Correct.
Right. So I don't want people to go think that we're talking about branched
right.
chains. So perfect. And then just in terms of just a general overall kind of wrapping up the whole muscle building thing, I don't know. Are you familiar with a lot of the theory with myostatin being like one of the main drivers of the rate limiting, how much muscle somebody can build? There seems to be crazy evidence in one direction, and then there's others where it's like, well, maybe it's not this. I just was curious of your thoughts on this, because they have I think it's those oxen that are like those. Have you seen these Belgian blue?
Double null myostatin knockout.
Yeah. So give me your thoughts on this. I'm curious what you think.
Yeah. So the thought is that myostatin is one of these sort of breaking things that doesn't allow you to accumulate a lot of muscle, right? And we do know from the Belgian bulls, which are what they call a double null myosin knockout, meaning there's two genes that code for it, and you just whack both of them out. right? So you took the brake on muscle growth and just pulled it off entirely. In humans, that's really rare. I think there was a kid born in Germany that was a double myostatin null, I think, and large amount of muscle mass, but there's some debate on biopsy studies that the muscle isn't quite as functional as what we think. It's bigger in size, but the strength doesn't compare to, quote, normal muscle. There's some interesting, so the U.S., like most of this research was from Duchenne's muscular dystrophy, looking at dystrophin molecules, and that's kind of how it got started. And there's even some debate with some of the genetic models that in humans, if you could really get someone that's double myostatin null, would that be an advantage? And it's really debatable. Supposedly, like Flex Wheeler is like a single myostatin null. So the new thinking is that maybe we don't want to remove the brake entirely and throw it in the trash, that maybe we just want to pull it back somewhat. And my gut feeling is that I don't know if we'll be able to without direct genetic engineering, because the amount of, like, the longer we keep looking at muscle hypertrophy research, the more we just keep coming back to that it's this multi-domained, like super redundant type system. And I just talked to Mike Roberts at ISSN when we were down there. I talked to him and Lane Norton. We had this hour-long conversation about hypertrophy and pennation angle and all this stuff. And it just seems like some of the theories, like the myonuclear domain theory, where the little nucleus for it can only allow the muscle to get so big, and the newer thinking says that may not actually be true. Even the models of what we had of the actual fibers and how they arrange in three-dimensional space, there's some super cool electron microscopy where they've done it in three-dimensional modeling, and like the microtubules and all these other structures are probably more important than what we thought. So all that to say is, I think it's definitely a factor, but how much of a factor, I don't know. And without like direct genetic engineering, it appears we don't have a lot of control over it. And if we did, it might be not the best.
Yeah, I bring it up, Mike, because I want people to understand. I'm gonna go down a couple more things here. We're in a society right now, unfortunately, where kids are very influenced, right, by social media, and they want to get big, they want to get jacked, and they hear things, right? And there's all these things that we're discussing about protein and muscle, and that they're just not thinking about, right? I brought up the whole mTOR thing. You hear this is good for you, but I want to do this too because I heard this, and your goals aren't matching up with what you're trying to do. Myostatin, I'm saying, is clearly a genetic thing, right? So so there's a component there that's clearly genetic. The other thing is you brought up Flex Wheeler. Those who don't know, Flex Wheeler was one of the greatest bodybuilders of all time in the 1990s. He looked like he was going to surpass Dorian Yates, but it wound up being Ronnie Coleman. So Flex Wheeler, so from that experiment, I don't know if you saw this, that they did a whole bunch of Olympia competitors, and it turns out these anomalies were not as common as they thought. But that brings me to my second point, is that some of it is just the androgen receptors, right? Some of it is just some people just have unbelievable androgen receptors, and especially those people who are taking anabolics, they're just unusual responders to anabolics. So when you're looking at these guys and again, Mike, I hope you're on board with what I'm saying here. Like in professional sports, they're all on drugs. Like they're all on replacement testosterone. They're all, at 200, 250, milligrams a week. Yeah, they're not taking 500 mLs with the anadrol and everything else that these other guys are doing. But these guys are all, quote unquote, maximizing their testosterone levels. You see these guys, all you have to do is go back and look at, my old baseball cards of Barry Bonds and Juan Gonzalez and all these guys in the 90s. I have been lifting weights my entire life. Okay. I am still 180 pounds. Yes, I can bench press, 320, and yes, I can deadlift 550. Yes, but I am 180, and it's not because I'm not trying to put on muscle.
Yeah.
To that point, Mike, just along with myostatin, there's just other factors in the receptors itself with androgens. And if you're taking anabolics, some people are just hyper responders. And I'm mentioning this again because there are so many parents with kids who are so influenced by things. And now these kids can get things like SARMs and get things, peptides like right through the mail. And they think that they're taking like a supplement when what they're actually doing is they're crushing their natural body's ability to create testosterone at the very least, right? So that's why I bring these things up. I know that was like kind of a long rant, but any thoughts you have on that?
Yeah, no, I agree. And there's a huge difference between, even if we take testosterone, right? It's a huge difference between natural production of testosterone and even using what's considered now a small amount of external testosterone, right, steroids.
Right.
Like you end up being in what's called the supraphysiologic range relatively fast, and again, that's highly different depending upon the individual, depending upon their androgen receptors, depending upon how they tolerate side effects, how they tolerate everything else. Some people are just more responsive, period. Like you even look at like Ronnie Coleman before he ever used any extra supplements. He was a freak. Like look at pictures of Lee Priest when he was 18. It's like, what the hell? I mean, these guys were the outliers, the freaks of the freaks before any of that. And I think that's the part that people don't realize either, especially with high-end athletics. It's not to take away from, the work and everything that they put into it. It's just, there's just some people that are genetically or whatever things we don't understand, just quite different.
Yeah. And that's, that's what I want to drive home, for parents listening, because there's so many kids right now, Mike, I'm telling you, I've been doing this for 20 years. And in the past 5 years, I have seen two ends. One is either the kids are getting super, super heavy, or they're like way overtraining and getting super obsessed, super OCD and going nuts with things. And that they're trying to take every supplement, every pre-workout, we're in a society right now where like nobody can just be in the middle and bother to learn something, like learn it, right? Instead of everything being promoted to you or listening to, the easy ways out. Understand what are the genetic factors. How does protein work? What about sleep? What about training itself? What about, how often should I eat? What am I actually trying to accomplish? And is what I'm doing getting me there? Is it the best way? Because like I said, my concern and what I'm seeing is how accessible these things are to kids. And they're doing like, Rad 140 and all these like crazy SARM things. And they think like they're taking a supplement. It's like, no, you are literally taking away your body's own ability to create testosterone and you're crushing it. And if you keep doing it, there could be, long-term problems, hypogonadism and how reversible is that over time? I mean, ask some of the professional bodybuilders that are now on testosterone for the rest of their lives because of what they did to themselves earlier.
Yeah. I mean, I know a couple professional bodybuilders, I won't say their names, but the handful of ones I know who like legitimately competed on the Olympia stage, all of them are on HRT because they said they tried to go off. One guy in particular, he's like, I didn't want to be on anything. He's like, I stopped competing. I didn't want anything to do with it. It's not part of who I am. Business transition, everything. And he's like, I just have no production, like zero.
Like, Jordan Yates was forward about it on Joe Rogan. You see how different his body looks now. And he just says, look, man, I have to take, exogenous testosterone because I just can't make it anymore.
Yeah.
And so, so again, I just want the takeaway to be, look, take the time to learn, understand. If you want to build muscle, there's actually these check marks, these boxes that you have to check off and understand. Let's talk a little bit about training itself, Mike. If the goal is to put on as much muscle as possible, which isn't necessarily everybody's goal, right? But if somebody's trying to put on as much muscle as possible, people talk about, reps and sets. And the biggest thing for me is, you and I both know Pavel Tsatsouline for a long period of time. So, I try to tried to follow a lot of Pavel's principles, which isn't just Pavel's principles. It's been around for him, but try to stop about a rep or two before failure. And I think the problem is that nobody ever realizes or takes the time to realize what is their actual failure, right? So if it's 225, if you're benching 225 for 5, right? If you know that your 5th rep, you can't get your 6th rep, right? For example, a lot of people don't ever bother to find out, what can they actually get to before we can start to figure out, well, how many reps do I have left or should I have left? And if we're talking 12 reps, there's a big difference between 12 and 3 rep max. Some people are really good at those, higher reps, if that's what you train. And there's genetic factors to that as well, as opposed to somebody that's really good at 3 rep max. So talk to me a little bit about, in the context of rep schemes and training in general, what do you find to be the best way to maximize hypertrophy?
Yeah, my bias is I like what's called a U stress model. So U stress, EU stress you can generally recover from relatively fast. So I'll look at, let's say you're just doing week-to-week changes. I'll take each week, we'll kind of slowly ramp up volume over the course of 4 to maybe 8 weeks. We'll do a little bit of a taper where we just slash your volume. You'll do some AMRAP sets, right? So we kind of push you a little bit to failure to know how many reps you can get with that weight. And then the next, we'll just start with the next phase after that. Within each week, if they don't have any, let's say, strength goals per se, they're not trying to be powerlifting or they're not trying to be a hyper specialist at one lift, I'll just try to move as much stress as I can out over the course of a week. So instead of having Monday be the classic destroy my chest bodybuilding day, you may bench press on Monday, but then you may do dumbbell press on Wednesday and military press Friday, right? I'm going to try to move that stress with heavy loads out over the course of the week to allow your body to recover a little bit. Most people, looks like a Monday, Wednesday, Friday, maybe Saturday is kind of main lifting. Tuesday, Thursday is a little bit more easier cardiovascular stuff. And then the goal is to pick exercise selection that allows you to accumulate the most amount of volume. So, trap bar deadlifts, squat, vertical press, bent over rows. And you can still add in some accessory stuff. I think that's fine. But most of it would be geared around lifts that allow you to put your body under the most amount of stress. Just because if you're doing a trap bar deadlift, you can get more load on your body than you can a preacher curl. Doesn't necessarily mean preacher curls are bad, but in terms of the priority, putting yourself under load and using lifts you could move the most amount of volume, that's going to be the priority. And then as you walk through each day, you'll get into some lighter accessory stuff. Yeah,
beautiful. I mean, volume being the key at a particular percentage of, of a 1 rep max or 3 rep max, whatever. So along that concept, Mike, let me ask you this question. So, because I think the term volume can get a little bit tricky in this regard. So if I were to take, just because this is the easiest thing to use, pull-ups. If I were to do, let's just say I can do 15 pull-ups in a row. If I were to do a pull-up ladder, right, 1, then 2, then 3, all the way up to 12, it's a lot of pull-ups, and that's a lot of volume in a short period of time. Let's say I do it all in a 20-minute time, right? That would have a very particular training effect, as opposed to, greasing the groove, where if I did a pull-up every hour. Right. That over the course of the week, I would get the same amount of pull-ups in the week as I did in that pull-up ladder. In fact, I'd get more. But I'm curious what your thought is in terms of the muscle response, in terms of what's going to happen after that up to 12, that pull-up ladder, as opposed to the person who greases the groove. I believe that the person who greases the groove once an hour is really training nervous system, and they'll get really, really good at pull-ups, but they won't get the muscle effect that we're looking for in that short period of time when it comes to pure muscle hypertrophy.
Yeah. If you would have asked me a couple of years ago, I'd say I probably agree with you. And now, man, I'm not so sure. Because there's been a couple...
Man.
Yeah, there's been a couple studies where they've replicated this now, where they took a group and they said, okay, we're going to volume match a group at like 85% of their 1RM, and then we're going to have some group do like a rep stuff, right? So a simple example, and I can't remember what exactly they used, is let's say you're going to do 10 sets of 3 reps, right? So you're going to do a lot of sets, but you're going to do a low rep per set, and then you're going to do like a 3 by 10, all right? Old school DeLorme. So you're going to do more volume, it's just distributed different. So both groups are volume equated, but they're inverse of each other, right? The 3 by 10, you're going to get a lot more local fatigue. It's just going to take you not as much time, etc. The studies that looked at that, which again, they're short term, doesn't show much of a hypertrophy difference between them if the volume is equated. The group that did the 10 by 3, though, did get stronger. And the downside with the strength group is they usually tend to complain that trying to do that type of training for the entire study was horrible. They hated life and their joints hurt. So there's a pro and a con to both of them. So I think if you're trying to get stronger, doing more volume at a higher percentage is going to be good. And I think if you can get enough volume, you can probably still get some of the hypertrophy response. The hard part is, like you said, you end up with issues of potentially recovery. Could you come back in and do it again? Because it's the volume scaled over time that's going to matter. And then are your joints hating you? How much time do you have in the gym to do it? So I think if you were to give if volume is equated, I think the hypertrophy response is probably going to be relatively similar, would be my guess.
Yeah, the thing that I hate about these kind of studies, Mike, like what you just cited, is, and I don't have to tell you, is that it's very easy for people who are untrained to start using joints instead of muscles.
Yes.
Right? So if I'm going to do pull-ups, like I know that I'm going to, engage my muscles and do the pull-up, and I know I'm activating, or a push-up, right? People get like up in their shoulders, and it looks nasty, man. They're sagging their backs.
Yep.
And this is where you get joint problems, and you're no longer, properly training muscle. You're not thinking about getting tight and packing your shoulders and what your scapula is supposed to do. So in studies like this, I always take it with a grain of salt because, training is a skill,
Yes.
and knowing how to activate muscles is a skill. If you ask somebody to do something for 10 reps as opposed to 3, of course, the 3 reps is going to look better than the 10. By the time that person gets to 5, 6, 7, and 8, they're just miserable. Their form is breaking down. They're no longer activating muscle. And so my point is that if you're taking somebody that's highly trained and knows how to activate muscle, get tight, use the appropriate mechanics, that's where I speculate that the pull-up ladder, in terms of hypertrophy, right? Not in terms of whether or not that person will do more pull-ups in a single event in 3 months from now. I think, grease in the groove, that person will almost certainly do better than the person doing pull-up ladders once a week, because they're training the nervous system nice and fresh. It's perfect reps. You're getting the volume over time. I'm just talking about the aesthetic component of them. That's my point. I mean, there's no right or wrong. I'm just giving my thoughts.
Yeah. I mean, I generally agree with the principles. I agree 100%. It's about activation. It's about quality of work. Do the highest quality of work you can over time. I do think that the old myth of low rep training is only central nervous system stuff is kind of going away. Just because that amount of tissue is still under load.
Yeah, I'm not. So let me just be clear. I'm not saying that it's only central nervous
system. Right,
that
it's primarily.
Yeah, you have the benefit of being fresh.
Yes.
Get rep in when you're very fresh, and therefore the form is perfect.
Yes, I agree. Because you've removed fatigue from the equation. Yeah, I agree. Yep.
I know we're running out of time. Let me get one more thing.
Yeah, no worries.
So last time we talked, and it unfortunately got really kind of messed up, but we talked a lot about magnesium at one point. And just, Mike, can you talk about, so I'm going to give you a situation. I have a client whose 18-year-old son has high blood pressure, and he's not particularly heavy. I know how the kid eats. He doesn't eat very well. He eats pretty much the same foods all the time. My immediate thought was it's an electrolyte issue because I know what you eat. And It's also a hydration issue. So do me a favor, get more magnesium in. And I told them to start with 200 milligrams of potassium 3 times a day, and see what happens as you hydrate. So I also wanted them to do the blood glucose monitor because I wanted to rule out type 2 diabetes. And but just in general, Mike, if you could just talk about, my thoughts on that first of all, and also just how hard it is to like, even as a healthy eater, I find it hard to get 4,500 milligrams potassium, and never mind. And I'm training hard. So the harder you train, the more you do, the more you pretty much need. And keeping these electrolytes in balance and sort of the key takes. Remember the last time we also talked about salt and things like this?
Yeah.
Just give me your thoughts on some of this stuff.
Yeah. I mean, I think the biggest thing that's changed for me, if someone is very healthy, doesn't have any metabolic issues, is eating very good, I actually think they're probably low in sodium, which we talked a little bit about last time.
Yes, we did.
That's something I wish I would have looked at sooner than what I did. I think magnesium is the next one most people are going to be low on, right? Just scan their thing. If they eat anything green, probably a high amount of magnesium, like green Skittles and M&Ms don't count. But most people are going to be pretty darn low. So like you said, adding supplemental magnesium I think is very good. Dr. James Lavelle, I got that tip from him. Like, he has high-end athletes where he just gives them a shit ton of magnesium, and he's like, oh my God, they feel amazing the next day. It's like, so even high-level athletes sometimes are low in it. Potassium is one of those that can be low depending upon where they get from their nutrition. So that's definitely one to look at. The good part is your body will tend to regulate electrolytes okay, but that doesn't necessarily mean it's the best for performance or long-term health, right? It doesn't mean that you're going to drop dead because you didn't eat sodium one day. Your body's going to figure out a way to make it happen because it has to. But again, that comes, I think, at a cost of potentially longevity, potentially acute performance. Like, you'll definitely see changes in performance and just how you feel, though.
Yeah, beautiful. And just in terms of how, poor electrolyte, or meaning literally not enough magnesium, not enough potassium, having these ratios way off, how it does in fact affect your blood pressure, along with obviously being dehydrated, that these are things that people aren't thinking about and are probably the biggest elephant in the room when you think about what electrolytes do. Like, they literally conduct electricity, right? I mean, this is what's happening. That's how your heart is beating.
Yeah, all your cells have to maintain a gradient of a certain amount inside the cell and a certain amount outside the cell. Like, literally every cell in your body has to do that. So it's one of those things where your body has to figure out a way to accomplish it, but it may throw some other stuff under the bus to make sure that happens.
Yeah, beautiful. Mike, I appreciate your time so much. I mean, it's been a little over an hour now.
Oh, yeah, cool.
I could do this all day, literally, but I can't thank you enough for the conversation, and I got a lot out of it.
Awesome. Yeah, thank you so much. I really appreciate it, and it's always good talking to you. It's always fun.
I'm going to keep you posted on that research on those constant blood glucose monitors.
Yeah, let me know what you find. That would be super interesting. I think that'd be quite eye-opening for people, too.
Yeah, I'm going to take your advice on that first week. I love that idea.
Yeah, and that gives them the comparison then too, because some people will be okay, some people are kind of a train wreck. I think just having that really good baseline is like super useful for people.
Awesome. Thanks again, Mike, for your time.
Cool. Awesome, man. Thank you. Bye-bye.
Have a good one. Bye-bye.
Thank you so much for listening to the podcast. A big thank you to Thomas Phillips for all of the great questions. Really appreciate it. You can find him in the link below here at Fit for Life. We'll have the website linked there. Thank you to him. Hope you enjoyed all the questions there. Thank you so much, as always, for listening. Really appreciate it. If you can help us out by hitting subscribe, downloading the podcast, sharing it with any of your friends. As always, leave us a comment or whatever star review you think it is worth. I read all the comments. Anything that you would like to see on the podcast or topics, drop me a note. We would love to hear from you. So thank you so much. Greatly appreciate it. Talk to you soon.